Hello, everyone. With Sarah down as chairing this, but apparently I'm Sarah for the moment.
So much prettier.
Yes. Yeah. Hi, let's just start in the usual fashion of letting everyone know who folks are up here. I said who I was yesterday, but for people who have arrived today, my name is Stewart Clark. I'm a physicist in Durham. I've been using HPC for many years, both using and programming that for various areas of electronic structure research. As part of that, not only have I been interested in the software, but also the hardware as well. So I've also been involved in sort of many hardware procurements, etc. So with respect to anticipating needs, both from the sort of software and hardware side of things, has been sort of part of my remit for quite some time. And if we just sort of go along the table, we'll start in my left and work our way along.
Okay, my name's Andy Turner. Is my microphone?
And I think he's turned it off.
No, it's on. My name's Andy Turner. I work for EPCC at the University of Edinburgh. Primarily, I'm involved. Press buttons pressed. Any better?
You pressed it twice.
Is that better? Right, obviously, I'm rubbish with technology, right? That's why I'm in this job. But my name's Andy Turner. I work for EPCC at the University of Edinburgh. My primary focus at the moment is working with the Archer 2 service. I provide some sort of technical leadership for the CSE team, who are the group of people who help users port and optimize their codes and run them on the system and be able to use the system. But I have a sort of long-standing interest in looking at the usage of the system and which codes are used and which communities are using which codes, how trends are changing over time over the different national services we've used. So I guess that's why I'm sort of involved in this anticipating session.
Karen?
Hi, I'm Karen Bauer. I work in Durham University as part of ARC's platforms team, so I help look after two systems. It's Durham's internal HPC service and also the Tier 2 bead service, and I help the people who use them as well. And in the past, I've been very much focused on more of a human interface to systems. So I've been the person that people have approached to ask about what they want to do. If you not hear it, I can hear myself. Strange. So I do have a background in being that liaison person between the researchers and the system on the other side.
Hi everyone, my name's Emma Barnes. I'm the Research and High Performance Computing Team Lead at the University of York. So within my team's remit, we have a small group of RSAs, and we also look after some of the infrastructure as well. We have a cluster called Viking, which we sort of look after, and it's a multi-purpose, multi-disciplined machine. So we get a lot of users who need assistance and help to access these facilities, and we do a lot of work there. In terms of anticipating needs, we've got a huge piece at the moment just looking at digital humanities and how we can improve what our offerings there, and we sort of try and do our best to facilitate people's research across the university, and however that would manifest itself.
And, you already introduced yourself, Mike, earlier.
Yeah, no, you're sick of me. So, I'm Mike Payne. I have a very similar profile to Stewart. I'm from the University of Cambridge.
Right. So let's sort of kick off this session on anticipating needs in a sort of rather general question. I'll let you interpret it in any way you like, and with respect to your own experience. So what does it mean to you to sort of assess or anticipate researchers' needs? Can you give a sort of brief outline of how you may actually go about that? And that's a very broad question, but narrow it with respect to the way in which is appropriate for the role in which you're currently in. So I was going to start at one end and go to the other.
Oh, okay, fine. We can do that. So,
sorry, Andy.
No,
yes.
no, that's fine. So I guess the role I see, part of my role in Archer 2, particularly as part of EPCC, is to look at trends on the system. What are people doing, not just in terms of the codes they're using and the scale they're using them at, but also in terms of how they might want to access the system, where are researchers coming from, is there anything we're seeing on the service desk that's a change or requesting functionality that we don't currently have that we maybe should be investing in for the future? Or, if it's something so different that we can't meet it in the current service, how do we feed that information back to the people who buy the national services, the research councils? How can we feed that requirement into future service procurements and things like that? So it's a bit, I feel like it's a combination of user community watch and technology watch in some sense. So that involves being in contact with the user communities via various scientific consortia, or also speaking to individual researchers, monitoring what's coming in on the service desk and what people are asking for and what people are having problems with that doesn't work, as well as anticipating how can we fix that. And also look at the statistics of the system, how people use it, what does the feedback look like, what are the stumbling blocks, what are the things that aren't quite working, or what are the things that are working well. So I guess that's the sort of view from the sort of national service and the service provision side of things.
I think I'd say yes, all of that, all the community watch and the technology watch. And also, Alison put up a nice slide earlier that showed how you'd go about finding out somebody's needs if you're an RSE, and it's the same. You start off with the research question, what are you doing? And try and get the bigger picture, because often we get a question coming in saying, I need to do X, but actually that person is probably working on the whole alphabet, and you can give them a much better answer if you know more about that alphabet.
I think that's sort of similar in terms of trends and seeing what comes in on the service desk, but some of what I try to do is to sort of actually physically go out and talk to people, talk to researchers within the university who may not even have thought of using HPC or anything like that. We found that some people didn't know some facilities existed, so just advertising that facility is there can suddenly open a whole new sort of world of research to people. And I think national trends as well is quite important, because you talk to people here, you talk to people in other sort of communities, and you see that digital humanities is a big topic, machine learning is a big topic, and then you can sort of start to decide, okay, the next procurement or the next physical piece of kit I'm going to get, I need to have a bit of a focus on this, just in case that does come to our university.
Mike?
Yeah, I'm not sure I really have very much to add except for one counterpoint, which is that, sometimes you get, well, yeah, we've heard this already, that everyone's overworked, you have far too many things to do. So actually a really critical point is deciding which things are actually the ones that you listen. I mean, everyone says they want everything, yes? I mean, there was some reference this morning about why haven't we got GUIs for everything? And that's actually what we discussed in the, we were meant to be doing the sort of meet your researcher thing, but actually it turned into much more of 101. I mean, a GUI is horrendously hard. If we think looking after scientific software is difficult, maintaining a GUI over a long period of time is infinitely harder. Yeah, we'd all love it, but realistically it's not going to happen. It's like the thing I said this morning about, you're not going to get 20 years of funding to support something. So crucial thing is, if you've been deluged with the requests, I agree that outreach to other societies, particularly from HPC, reaching out to other disciplines that aren't historical users is very important. But there is also this risk that, everyone wants everything, yes, and they don't have any money to pay for it. So, anticipating needs is sometimes actually, I know what's going to be happening in 5 years' time. I know what's important. And actually, I'm not going to listen to all these sort of very short-term, actually not very important things that are coming in, because I'm going to actually do something that will really have impact in 10 years' time. I mean, when I was developing CASTEP, everyone said, oh, I've got to do this. I had the industrial saying, why aren't you doing this? And all of that was actually pretty irrelevant. It was more about where we're going to be in 5 and 10 years' time. And how do we get there? All right, so you're more in the middle. I was able to drive that as a research program. But knowing what is actually worth doing, what's going to engage a big community rather than just a one-off project for one person, is really important in this space. As we know, we don't have the resources to do anything. And the thing that's hardest, and where you really need the leadership in RSE teams, is when you've got, the bullshit academic who's going on and on saying, why aren't you doing this for me? And that's where you need your sort of manager at the top of the team to say, well, because actually it's a bit of a waste of space and you're really not very good. He'd probably say it more diplomatically than I would. But then maybe you need your your friendly academic who can actually, or vice pro VC or whatever it is, that's actually up that line management to put people like that in their place. I mean, I have noticed, in the lab where I work, all right, this is IT, not RSE, but have you ever come across an IT professional who doesn't walk around saying, I got 500 requests to do things, all right? And that's just their excuse for doing nothing. If you walk around with 500 requests to do something, you will achieve absolutely nothing at all. All right, RSE isn't quite that, but there is the same problem. You get far too many things that people want you to do, most of which probably really aren't that important and that worth doing. So the focus on the things that really matter is absolutely crucial. And having a system in place in your RSE mechanism in your institution that actually will defend you when you make that decision is absolutely critical.
Yeah, just following up on that, one of the issues I have with anticipating needs when you're speaking to people, I don't think they're very good at anticipating their own needs. They will tell you what they're doing now, maybe tell you what they have done, and when you ask them, okay, let's move 5 years into the future, they'll just say, oh, this bit bigger. Yeah, and that's the most common answer, it's like no, you have to, what science are you doing? Are you going to be doing the same science? You just want a bigger machine to do the same thing. Will your algorithms change? Will your methods change? Are you going to just simply sort of continue with that program that your PhD student wrote 5 years ago and use it forevermore? So I find it incredibly difficult to extract the needs of the users. So, for example, when we were doing some of the Archer to procurement surveys, etc. Essentially, everyone just says, "Can I have it like Archer but bigger?" And that was essentially the single most common answer.
I think we touched on this a bit in the sort of bringing people in and talking about, it also exists in bringing new communities on board. It's incredibly difficult for researchers to imagine what the possibility is for their research until they've actually got hold of the thing in front of them a bit, or they're seeing the problem, say, with their algorithm not working on a different architecture or something like that. It's very difficult for people to do that imagination. And I guess that's what the value a lot of people here bring, right, is research computing experts. The idea is exactly what it's like what Mike said, right? You're taking all the information in and you're synthesizing it into something that's meaningful and prioritized, that actually has the impact long term. So you're taking in, you've got to take into account things like the strategic side of things, both in terms of your organization, but also UK funders, along with what researchers are telling you that they might need, whether you think it's right or not, along with then your own expertise of being in the industry and seeing how trends change and how things do, and synthesizing that all into things. That's the value that people here in this community provide, is that sort of synthesis, right?
Mm-hmm. And then, of course, you brought in things like funding, etc. There, you mentioned it, and so getting funding for the future is incredibly difficult. And if we simply say our anticipating needs is just more of the same, please, that's an incredibly difficult sort of political game to play. They'll just say no. They want something new and big and shiny that generates excitement within the non-scientists above the research councils who actually eventually make those decisions. And so, if you actually just going down the route of the death word in any grant, incremental, then you really have to be very careful in doing that. It's unlikely to take you very far. Maybe we can actually open up a little bit to folks. I mean, there's with respect to anticipating needs, does anyone have examples of something that actually is useful to add, where it's more than just I want a bigger computer? Yeah, because that is by far the most common common comment that I ever hear. So if we a couple of us, so there's whoever gets microphones, microphone for Matt, microphone for Peter.
Hello?
Hello.
Okay. Yeah, so there was one that sort of emerging technologies, it's useful to have software stacks for those, on new machines, that sort of thing. Things that maybe aren't super popular, but are maybe rising, or maybe be worth testing to see if people will use them if they're available. I know for Archer 2, for example, there was the Python stack that was insisted upon, that from Cray, that they give a working Python stack. That's not all that common on HPC machines to have it actually consistent and work. So it's that sort of thing where it's slightly off the beaten track, but it's useful, and it may be more useful in the future.
Thanks. Matt.
One I was going to raise was an example, picking up Mike's point a bit, of where users request things that aren't actually right, and you have to make a judgment call that what they're asking for is not right. And the example for this that springs to mind was part of the Archer procurement after we were moving on from Hector. A number of users saying, we want GPUs in the national facility. And okay, GPUs were coming out, they were a big thing, there were some nice headline figures. The problem was, the codes people were using weren't ready to be used on GPUs on that machine. If we had spent all the money on a GPU system back in those days, we'd have blown a large part of the budget on a machine that most people couldn't use. And even now, we still don't have GPUs in the main machine, but we do have it in a lot of the tier 2 machines as a way of getting people to rewrite their codes. And it's users who come across, they come across this new trend, new buzzword, and they say, we want that. But they don't understand, or they need to be educated, that brand new shiny tin doesn't always help them. You need a whole stack of stuff to go with that, including all the software needs to be rewritten or adapted to run on that new hardware.
I do think there's a big challenge here with that side of things. I mean, this is this balance between, research output business as usual and actually being access to technology that is coming up in the future and that you're going to have to work on. And I think it's been very difficult for, particularly in the national service, to get that right? Because it becomes as a big monolithic system. Actually, you really need it now to produce science now. So you need the ones that use exactly what you said, right? You need codes. Well, you do need to prepare the community for the future, and the tier 2s are supposed to do that. But I think it's not moved things forward as much as we need to, in some sense, of being able to exploit accelerator technologies, which are going to be the core of any very large system going forward. I mean, obviously, there's always the chance that it's some sort of Fugaku-like system, and you end up with a CPU. But I think this sort of risk, business as usual thing is a hard balance to get. And I think we've struggled to get that right in the UK on the national service in particular. I think we've particularly been quite risk averse in terms of...
Can I follow up on that? Because I'm not sure if Matt was actually there, but I remember walking back into my research group at the end of the procurement that led to the HPCX machine. And I walked through the coffee area, and all these people were saying, "You've done what? You've bought what machine?" And of course, the HPCX was this IBM machine where you had sort of shared memory among groups, and then really poor communications compared to the previous generations of parallel machines between the groups. And it's like, this is rubbish, it won't run CASTEP. And I said, yeah, that's right. But actually, it's a model for way the things are going. And when multi-core came in, the point was CASTEP had adopted to HPCX. That was your trial way of developing towards multi-core, which meant that you went seamlessly onto multi-core. So in fact, that was a very, very adventurous decision. It also, we beat IBM down by a factor of 6 in their price for the machine that we got. And actually, the one thing that was devastating was that I think, CASTEP and maybe 1 or 2 other codes used that opportunity to get ahead of the game, and no other codes did. And then you hit multi-core, and of course everyone was dead. But there was an opportunity at the national level. A halfway house, local distant memory. Get used to it. That's the way things are going, And it was risky. Mm-hmm. Very few people took that opportunity, and that was, disappointing, I'd like to think it wouldn't be so bad now, but, it's before RSAs. But, we really did try, Yeah. We also got a pretty good deal out of IBM. That was really good. Factor of 6. First price to final procurement.
Yes, Alan.
Yeah, I was about the kind of anticipating needs, and one of the anecdotal stories that kind of went through my mind, I was reminded of a story when I was at Leeds, which is really the moral of the story is often you kind of sometimes have to look to the dark corners of kind of the community to figure out where some of the really new, interesting needs are that might help a whole community or other communities of people. So the story really is that, so some of us may remember when the whole, the volcano in Iceland went poof, right, and the big cloud. And the sort of NCAS people based in Leeds basically got a big phone call and said, right, stop everything, right? You're going to run some simulations to figure out where on earth this cloud's going to go, all this kind of stuff, right? So all kind of Archer time, was it Archer time? No, probably Hector time at that point in time, got allocated to do this forecasting. It ran this stuff overnight. It was all wonderful. And then the data analysis stage had to kind of happen, right? And they went, right, SCP file to Leeds so that we can actually do it. And it went, okay, great. It's going to take 2 weeks to transfer that so you can do your data analysis. Okay. And hence now we have things like Jasmine, right? And we started a whole networking conversation around how we might do better point-to-point transfers. But, and we thought if we can prove that kind of example and have this embarrassment of being able to react in this way, we can actually create new capabilities for our communities.
And then just from the online audience, just saying that there's a constant challenge in balancing the call for multi-GPU machine learning model support against simply GPUs with bigger memory. It's a challenge being faced there.
Yep, that's right. There's the sort of current architectures are getting massively large core CPUs, etc. And if you found that you were doing, for example, your parallelism was MPI for long, you've now lost the plot on that. It's not the efficient way to do it. Just generally sort of ask around the folks here, how many people actually consider several forms of parallelism or what they might actually be running their code on in a few years' time when writing it? Or do you actually just think, here's what I've got on my desktop at the moment and that's what I'm writing it for? Just sort of general sort of question to our research software engineers and others. What do you think about when you're actually writing a code that you think is going to be lasting for a while? Oh, was that the wrong question? Yeah. Oh, yeah. Excellent. Took a moment for that one. Yes. Yeah.
Is the technology that I'm writing this on open source?
I mean, it's it's just sort of general open question. If that suits you.
That's one of my key things.
Sorry. Yes.
I want to make sure that if I'm using something that I want it to be open source.
Mm-hmm. Okay. Yeah.
My considerations is usually what the maintainers of the code will be. Is that okay, I'm updating the file management and whatnot sections of a particular simulation code. Is that I need to have that fit within their existing framework, make sure that the library requests aren't too heavy, and that they can continue to use it as close to their existing stuff as possible. If I was doing a full rewrite on something, that would be different. But I imagine lots of folks are tasked with refactoring subsections, maintaining aspects, and interactions with the PIs and the future maintainers is probably my biggest sort of thought on that.
So that's what we seem to do all the time. Actually, it's we tend to do a bit of a rewrite of something for the machine that we've just got.
I'm not saying it's good.
Yeah, no, exactly.
I'm just saying that's the perspective.
Yeah, I think that's. I mean, it's the vast majority of things do this, where it's like, okay, I've now got to make it run faster on this. Yeah, and it's always the current thought. It's never, could I do something now that actually might make life easier on the next machine that's coming in? It's an incredibly difficult thing to predict. But it's one of these sort of thought processes that I think should be there. maybe it's not for you, maybe it's not the thing to do, but it's a thought process that should be there whenever you're actually writing code. Because I think one of the things we've all noticed is codes outlive machines. You can't rewrite a code every time there's a new machine. And so there's this thought process that should be going into the engineering that you're doing. Yes.
Okay, the answer to the question is go and talk to your local RSE or HPC centre and ask them what the future looks like, because they're the people who will have the longest vision in your institution. So have a chat with them, discuss those things, discuss your options, what you might be keen on doing, do a bit of vectorization, port it to a GPU, rewrite it in a sustainable form, have the conversation.
Yeah, I mean, I think that's happened. I mean, it has happened a bit, coinciding with the RSE community. Before and in terms of scientific software code development, there were lots of good examples of people who did do that, develop in that strategic way. Class step's a classic example, the long-term thought about where the code's going and what we have to support over time. But there were also a lot of codes where it was like, we need to solve this problem now, and, we need a code out that also solve the current research problem with no sort of thought as the long-term strategic, maintainability or being able to move the code to the next generation of technologies. That's changed a bit, I think, because of the RSE movement. People are a bit more aware that they can go and do exactly what Simon said and speak to an RSE. I think more people do speak to an RSE now before doing things which is positive. But I think that, and open source has helped a bit, but I think there's a huge complication, and it makes it very difficult to make a decision now. I mean, what does maintainability mean, and how do you do it? It's quite hard to think about that, because lots of people are so interdependent about things like Python frameworks and these things that are binary distributions, or how does this work out with particular containerization solutions? So the landscape is much more complex than the old days of HPC, at least even within HPC, which is pretty simple in software terms. In the old days of HPC, the portability was achieved by having source code, right? And source code that compiled with different compilers for different architectures and still gave reasonable performance and they did the science you want. That question of portability going forwards and maintainability is so complicated now with all the different intersecting frameworks and things like that. It's really contemplating the amount of funding you need to maintain the code going forward in that framework. It's just a massive part of doing things.
I think it would be nice if everybody did at least attempt to keep their code up to date. And I think sometimes people are a little bit precious about the code that they wrote decades ago.
It depends how much weight you have on the code, right? I think a perfectly valid approach is I have code that I throw away for each architecture and I just rewrite it each time, and avoid that complexity. I mean, it depends on the complexity of your problem and the size of community you're supporting. But if it's code for a small research group, it may be that actually the more efficient thing is to write the code, throw it away, do it again. I mean,
it's when you get the code that's several decades old.
Yeah.
So, for example, here, sorry, there's more questions. Did I miss a question? Yeah. Yes.
So just with my GPU hat on, I just wanted to add that I would love to write portable, performant code with an open standard. But until there is more than one vendor which supports these tools and provides a good developer experience, it's just not going to happen. Obviously, with the recent upcoming C++ standard changes and do concurrent in recent Fortran standards, it's certainly improving. But until there is actually competition from the vendors, and there are tools that are as good as the NVIDIA provided tools to analyze the performance of codes on this hardware, it's just not going to be feasible.
But just question to folks here: when you're writing your code, other than when there's no other alternative available, do you do things like compile with a range of compilers, make sure that you're conforming to the standards? Do you sit there worrying about that bizarre, obscure Python library that you import that no one else has? Do you sort of package the non-standard components up with it? So whenever you're writing such routines and things nowadays, do you actually worry about that someone will actually be able to do this even a year or two in the future on a slightly different machines, slightly different flavour of Linux. Jumping from Python 2 to Python 3, dare I ask? Things like this. There's a whole range of things here where I think when we're coding, we don't generally think about that at the moment, but sort of just open that sort of general sort of type of question up to people, well, here as well, but to get comments from everyone here. So hands.
Before we
just, sorry,
sorry,
is there one more before that we move on?
I was just going to go back to the question about user need, and I would certainly support users to contact the RSC team. But for users to see the future, sometimes they have to experience it. So I would encourage sites, but particularly services like me and Andy's, to actually build relationships with the vendors. They're the ones that have got new technologies coming through, and they can facilitate events where your users can experience new technologies with experts here to can see if their code is going to be useful for those emerging technologies. And then they would have a better idea of where their code might be going in the future. Because just because a technology is emerging, you have to not just decide whether you're going to get on board, but you have to then determine how you're going to get on board. I mean, take GPUs. There's 4, 5, 6 ways you can harness that power. You have to decide what is the best path for you, how much time you want to commit to learning that technology, so you can get the best out of your research.
So one of the things that's being discussed a little bit online as well is the fact that funders' RDM policies are mandating keeping data for 10 years plus. So they're talking about a massive gap in the long-term archival and storage for entire disciplines, and users hate thinking about these things in the long term, let alone doing RDM properly. So we need to be thinking about how to make it easier for them. And long-term archival and longer-term storage should probably also be particularly well integrated with HPC systems. And finally, Peter is saying, yes, absolutely, compile with multiple compilers, strict conformance to a given standard, multiple OSs, multiple MPI implementations. Peter, keen to make work for himself there.
Yeah, there's always this compromise between the ideal musts that should be done, and the ones you actually do. Unfortunately, some of the, if you get it wrong, it'll come back and get you. That's the problem. Yeah. I think there's a few more hands up. Yes.
Just come back with my Met Office perspective again. So this is the sort of thing that we do worry about because of our international collaborations and things. So the next generation weather model basically is abstracting away the parallelism into a system so that experts can actually take care of parallelizing over whatever the new technology is coming along, and scientists can just worry about their specific algorithm. And in terms of the testing thing, I don't know the precise details of the testing frameworks, but I know that we have multiple compilers that the code is checked against in the nightly builds. So for our code that's used between many different institutions and has to have this sort of robust portability, it's something that, this is not my area, but it's something that I know people in the office have done a lot of work on recently.
There's one up the back there. Yes.
Yeah, I'm a Java programmer, and in the past it used to, deep intake of breath. It's quite a long time since I used MPJ Express, which is a pure Java implementation of the message passing interface, run that on large-scale grid computers, but it did work. And one of the things I mentioned earlier was, is it open source? And that was, and it still works, but it's no longer necessarily actively being developed. And what I would look now, it wasn't actually at the time put in anything like a Maven repository. So it's there and it's on the website and you could get it and you could access it, and somebody has pushed it in there now. But it's, for me, I think the sustainability of the software that I'm using is key, as was mentioned by my colleague who's just sat to my right. And part of that is putting it into these trusted Maven or Maven-like things which do the checking, make sure the full documentation's there, that the testing suites will work, and that there's full coverage of those things.
Any more questions from or statements from anyone? Yeah, just as a little I'm still on my first question here, yeah, so I'm not. I'm chairing this slowly. But let me sort of pause before my next question, because I quite like the thing that came up there on the sort of the 10-year data. So you're saying maybe we can I'll work along the panel and get your thoughts on that. That kind of anticipating need or future need that we require for that. So let's start with Emma.
That's actually, timing-wise, that's something we're looking into quite significantly at the University of York. I'm trying to go from a point of building the infrastructure and making sure that is there first, because at the moment people have a variety of different places they can store their data, and from an academic point of view, that's a nightmare to look after. From our point of view, that's a nightmare to look after. And security and everything else, and doing a decent RDM plan it's going to be very difficult. So we don't currently have one sort of storage facility for research data. So that's what I'm trying to, and getting closer to creating at the university, and I'm hoping that will simplify some of the processes around research data management, and working with the library who do that section of things with ourselves, we can try to marry some of these pieces together going forwards. So I think it's something which we're definitely looking into, and it is important going forwards.
Give an example of where that's working.
I'm hoping it's going to work at York.
Because I'm unsure myself. It's one of these things that I think for all the sort of scientific computing we do here, and now beyond sort of in many areas of academic work, archival or data storage is an incredibly large unsolved problem. We all have our own even concepts of what we think is the data.
Yes, that's true. That's another problem. People don't think they actually have data when they do. Yeah. So I think there's a huge education piece on that side as well. It's not just going to, we'll get some storage in and everything's going to be suddenly simple. But from my current perspective, our problem is we don't have an integrated system right now, and we need to have that first before we can start building up these other layers. And a system where it's, we use Glacier for our long-term archiving. Something which
I hope you never have to pay to get it back.
So do I. But luckily it's not me who has to pay for it. But also, having something which is completely integrated, which we don't currently have at the moment. So other people might have that and can tell me it doesn't work.
I think
what's the barriers you're facing there?
Well, part of it is funding.
So going to your university or to research councils and say, I just want to store stuff. There's a in some sense an incredibly boring argument that they don't like. They want to, almost what I hinted at earlier on when we were going to machine procurement and things. They want something new and big and shiny.
Yes.
Rather than something that is
this is sort of medium term, longer term data, and it's not as exciting as that kind of this is the new shiny thing which we've created and going to do X, Y, and Z. We are getting there through talking to people for multiple years, but it's not been quick. Also, it's how do you pay for this longer term? So, encouraging academics to write into their grants, X price per terabyte for storage over a 5-year period. We've got some departments who are excellent at that, others who aren't. So, there's an education piece there that needs to be done. We still get surprises of, I need 20 terabytes now. Okay.
Coming back to the anticipating needs, I think this is one area that's quite challenging because we think users are bad at anticipating what they're going to do with future technology. With exceptions, most researchers are really bad at anticipating how they're going to store the data. So rather than just say, I'm going to have 20 terabytes of data and I'm going to keep it for 10 years, and then that's not actually useful, right? I mean, you're just going to have, you've just got really expensive dev null, then, or something like that, and you're never going to look at again. And so there's a huge amount of education to be done before, for researchers to be able to, for us to help researchers understand how they can keep data in a way for a long term that's useful. And you know, the problem is we're having to go away, or it's in the institution, not us, not me, Mark will be able to tell you more about the data side of things at EPCC, but you're having to go away and build things for people where it's quite hard to gather the requirements and to anticipate their needs, because the researchers themselves have little clue about what this actually means going forward. So I think it's a really challenging situation. I mean, I don't have a solution to that, because I think, well, certainly I feel I need educating about how you can store data in a structured way so I can give good advice to users. I don't think it's a place where I've got huge amounts of good advice to share, though there are lots of people with expertise who can. But I think it's generally in the community, it's one of the bits where we in the round and researchers have less technical knowledge. I mean, as a community in general rather than individuals, obviously, because some people are experts in this.
That's where library services been really useful, because they're used to archiving, they're used to, and that's where I'm plugging into. That side.
I think there is a problem that the researchers, when they're putting together their grants, they can see, oh, I'm going to need to do this computation and I'm going to need to cost it, so that goes in the grant. But the long-term data, that's afterwards, so they're not thinking about that now, and unless you make them think about it, then they don't. And the second problem is, even if you do get them to think about it and you've introduced the letters R, D and M in all your introductory courses, then they want to keep everything, and it's difficult to let go of things, so that makes it very difficult to know how much you really need to do this in terms of assessing volumes.
So part of your role is, for example, sort of university HPC. Do you have any experience there of users and data storage and what they do, what they shouldn't do, what advice you can give them?
In a previous role, yes, quite a lot. So I worked quite closely with the library and the research data manager there. We did a two-pronged attack to every postgraduate came in, research postgraduate get training if it was relevant, to say you must have an RDM plan there. And these are the things you need to think about, and you need to think about the risks to your research as well. And the word risk does help to focus minds sometimes. It can be hard, and then sometimes you get the people that say, yes, I have a backup, it's here. And they'd open the drawer, and then there's the backup. So it's a matter of getting away from that into a much more centralised and managed solution. I have no solution to the very long-term things where people have moved on and you don't really have an owner anymore.
Yeah. It's one of the things with this sort of 10-year storage, and the owners disappeared, and I'm not even sure I understand how the request for that data could happen. In some sense, it's we have it there. No one knows what it is. How would someone request it? To me, it's there's so many questions that's required before you even get to the okay. We are storing it for 10 years.
And you need the metadata in there as well.
Exactly.
Not just the data.
Exactly. Yes, but that's one of the major issues. Exactly. Yeah. Mike, have you anything to add in this?
No, other than it's a complete and utter nightmare. I suppose, fortunately, materials informatics, there are now some big sort of databases, and so we can dump our data in there if we want, which helps a little bit. But yeah, I mean, it's a typical example where someone thought it was a good idea without thinking through the implications of it. I mean, it's not clear from the requirements of us keeping our research data whether it's meant to have metadata or not. I mean, our calculations produce vast amounts of data which we obviously can't keep. So actually we've got this ruse, haven't we, where we say, oh, well, we keep the program, and we keep the input data, and we keep the output deck, and then you'll be able to reproduce the data. That will do. And everyone says, yeah, no, that's great. Failing to understand that, of course, if you don't have the computer that it was run on, in 10 years' time, you won't be able to run that program. But anyway, as long as we can con the funders and tick the box, better expunge that from the recording. Then but look, I mean, it's just a complete nightmare. It's a typical knee-jerk reaction and then a political statement without any understanding of what was being talked about. As I say, I don't think there is any requirement for research data under our research plans to have any metadata or be searchable at all. It's just that someone can grab that final output file and have a look at it to see whether you fudged it before the publication. I mean, it'd be lovely for it to be searchable, but that, vastly inflates the whole of the complexity. But yeah, it's just a horrendous problem, absolutely horrendous problem.
So, question over there, or comment?
So, Mark Parsons here. Nice to see you all. The thing about the research councils is, now that I have 1 day a week, I'm inside them and involved in the DRI program, is I asked the question about how each research council ended up with its duration that you have to keep data for. And it turns out that they mostly just plucked a number from the sky. Sometimes based on the fact that the medics thought they should keep their data a bit longer in case they were sued and things like this. But there's no grand plan around it. And one of the things that the DRI program is supposed to be doing is actually thinking about this properly, because they do know that the current situation is not the right position to be in with data at all. And I think just going back to slightly the earlier conversation, which is actually related to this conversation. My wife's Luxembourgish, and I won't say it in French, but she's got this saying that says there's nothing as permanent as impermanent. And from a personal point of view, I wrote the physics department's backup script in 1992. And
you're still using it.
In 2007, I got this panicked phone call one afternoon, and they said the physics department backup has failed. And I said, well, I have absolutely no interest. And they said, no, you wrote the script. I had no knowledge or memory of doing this, but yes, it was me, actually. And I think you can never, when you do these quick things, this is where the real danger lies, that they will just become permanent without you realizing. And this applies to everything, in particular, I think, on the data side. And Mike's quite right that the current way we catalogue data is a disaster, but it's a disaster of our own making. Nobody wants to create their metadata. And even when we try and make people create their metadata well, they still find ways to actively not do their metadata. And this happens again and again. And I spend a significant amount of my life at Edinburgh now in meetings where I suddenly realize I'm no longer in a computing meeting with computery people like probably most of us here are. I suddenly realize I'm in a meeting with librarians, and they have a different, so first of all, they don't call it data, they tend to call it collections, but they really do understand how to do this because they've been doing it for about 400 or 500 years. And we should really take some notice of them. But we are two communities that do not speak the same language at all. And I don't quite know how we square that particular circle, to be quite honest.
Thanks, Mark.
So the discussion almost kind of got there on its own before, I just want to say this anyway, but I'm wondering whether or not it would be considered a bit too heavy-handed to say, right, if you want us to store your data, then you need to meet certain requirements and look at the fair data principles in order to define what it is that data needs to meet. The metadata needs to have, enough provenance information, for example, and things like that before you'll say, okay, yeah, that will provide storage for you. And if you've just got, the CSV full of numbers and, it's not described or anything like that, and you say, no, we're not storing that, or would that be too risky?
I mean, one of the challenges here is that storage of data and metadata and all these things are quite community specific, right? So the organization unit is not university, it's scientific community, right? So the ones who've done this successfully are the people who've had to deal with this problem before. So the climate scientists, do pretty well with the with, for example, the Jasmine facility and stuff like that. There are rules about how you deposit data and what that data means, and it has long-term provenance. And also CERN and the Large Hadron Collider, and the people working with telescopes, they've all addressed this problem. But it's specific to that community. So one of the challenges, I think, very much for the onus has come back to the universities to do this, is the university is not a research community in that sense. So everything's different for each of the research communities in the university. So actually the right organisation is cross-university within research communities rather than in the university. But that's not where we've ended up in terms of funding and expectation from people.
Sorry, just from the online community as well, for fear of opening the discussion out yet further. It's not just the data and software that needs to be looked after when projects finish, but also the solutions, including web apps and cloud infrastructures. And obviously these solutions require a lot of support in order to keep them running, and very often there isn't any funding reserved for that as well.
Right, so that's us come to the end of the first question.
We're done now.
Next, sort of move on a little bit. What I've noticed is we have we're expanding out into what we might think of as somewhat more sort of non-traditional communities with respect to computing. So as much as we have often talking about here about scientific computing, there's a number of people here who are from sort of non-science departments, etc. So how do we anticipate sort of the future needs of the academic community as a whole now, rather than the sort of what would have been the traditional, I hate to narrow it down, sort of, computational scientists. We're now having a large number of non-scientific disciplines which also have compute needs, and hence software support and the whole sort of infrastructure that we are kind of getting used to here, but are not used to outside. Essentially, the sort of more traditional communities which a large number of us are a part of. So, how can we help anticipate needs of sort of the academic community as a whole, rather than sort of the narrow aspects that we are more used to working in? Would anyone like to go first on that one?
I can go first.
Yes, go for it, Mike.
So, interestingly, I'm going to be horrendously provocative here, which is that actually my observation, at least in the UK and other countries, may be very different. I mean, so one of the issues we've had in computational science over 30, 40 decades is that no self-respecting computer scientist will work with a computational scientist, which is basically why we've had to develop the way we have. But actually, they are very interested in working with other communities. I mean, the bioinformatics community is very clear, serving biology. You've got lots and lots of computer scientists helping them. My son, who is a classicist, he's doing a postdoc at the moment, is working on machine learning Latin poetry with a computer scientist, because it's a fun problem for a computer scientist. So actually, I just wonder whether, in fact, we have to be very careful and we don't impose a computational science view on expansion to other communities. That in fact, I mean, this is not going to be a complete solution to everything, but I think a resource that, for whatever reason, and we don't need to talk about that, has not actually really been very interested in the sort of stuff that I do, actually are rather interested in quite a lot of these other challenges. And I think that might be an interesting thing to look into if you are trying to facilitate communities talking to each other, as a way of beginning to address this problem. Discuss, yes.
Karen?
I'm going to say that sometimes in fields that are just entering the HPC maybe world, it's not the senior staff that make an approach, it's the students. So students have friends in other disciplines. So if I've been helping somebody in one discipline and their friend in, say, ancient history has a problem, the person I've already talked to might tell them, oh, go and talk to the HPC people, they might be able to help you. Go and talk to the RSCs, they might be able to help you. And that's sometimes a way in. And then you get to know the supervisors who may not be computational themselves, but have decided to develop this area. So sometimes you get in that way, and that's how you know the needs. And another way is to know the IT staff in that area, the local IT staff who are trying to help people do what they need to do, and maybe finding that a desktop is no longer the right answer. They're the people on the ground.
Andy, Emma, any additional comments?
So I was going to say I've been trying to break into this area for a while. My background's physics, but I find these problems interesting. but the best thing we've done recently was hire an RSE with a focus on humanities and social sciences at the university. We hope that will expand that. And they are a lecturer in the linguistics department already. They have a lot of contacts, and within the last 3 months since they started, I've talked to so many new people in so many different areas, and that's really sort of expanded that network we were sort of struggling to sort of access before. And, you know, there are a lot of problems which are very similar and some are very different. I think someone mentioned websites, and websites are a bane of my existence in terms of trying to look after. But, you know, it's trying to find ways to facilitate research, and if it is a website, how can we do that better in a more sustainable way? And, you know, or if it's HPC, how can we help people get to that level as well? But I think RSCs has been a real saviour for us in this particular area.
Well, I guess everybody hears, I mean, most of all the things that have been talked about here, I think are sort of the bottom-up approach, you know, the sort of building communities from the bottom and build. What I don't quite know is how we join up at the top, the sort of the UKRI level. Right? I mean, we were discussing this around one of the tables a bit earlier. I mean, one of the things I think is that, you know, there's a lot of discussion at the top level at the moment around an exascale system. And my understanding is I think that's a UKRI-wide thing that includes all of the research councils and their requirements for computing into that conversation. So, you know, you never hold out too much hope of departments getting together and talking to each other. I mean, I think EPSRC and STFC and NERC, and to a lesser extent BBSRC, all sorts of have an idea of what each other are doing around research computing, but less so on the other research councils. So I think that's my concern, is we can do all the bottom-up work we can through community building and stuff like that, but we need the top-down stuff as well. You know, even within UKRI, never mind other funding councils, to be a bit more, you know, what are the needs and how do they integrate those needs across the funding piece from government down?
So if we open this up for more general discussion, have people been interacting with some of the sort of traditionally sort of less computationally less computational communities? I know we've got sort of a number of folk who are from outside sort of science in general here, but it's also some of the RSCs, etc. Have you been broadening your horizons and actually being involved in areas which are less traditional for our computational science? And you know, what have the needs been, and you know, what direction do you think it may be going in? So.
I think there could be surprises here in that some of the arts and humanities communities do a huge amount of computation. And sometimes there's surprises from different communities that you might think are not traditionally uses of HPC resources that actually have really high demand for that kind of thing.
Yeah, I completely agree with that. The arts and humanities, the AHRC are funding a couple of DRI research fellows at the moment that are looking at what sort of data services they need and how it might fit into a bigger DRI type of solution. Bizarrely, they've also shown interest in an exascale system, and that was a great surprise to me. But these are people that are doing image analysis of medieval texts, for example. There's some other people doing some really, really big linguistic stuff, which that's a great surprise. The Research Council that hasn't shown or hasn't found any big problems yet, sort of the top end of HPC, is ESRC, but they're at least having a think. And I think it's quite interesting trying to buy a system for all of UKRI rather than just the chemists and physicists is an interesting process, because it's got people thinking about it for a change, which I think is really positive, in fact.
Thanks. Any other questions? Yes.
Just a comment, really. And what, as a librarian myself, and I think the libraries, archives, and museums, they are encountering the biggest challenge as we are managing, or as a collection of new materials, and born digital materials, and digital oral history, and huge metadata of museum collections. Things like that is very new. And how we going to kind of, as from librarian side, we kind of transform those as data for researcher, and how researcher can explore those data and using kind of different tools for their research in future. That's a future needs. I think that's kind of the area is involving as kind of you as a technical aspect, professions, as well as library, museum, archive specialist, as well as researcher from all kind of three aspects to work together, explore the kind of new opportunities and solutions to kind of make any advanced research project. I think that's probably a way to explore, other than saying, we got this data, we got this researcher, I want just to use this data, because we three kind of actors are all working on the kind of new material at the same time, kind of explore the new research methodology as well. So that's how I feel kind of probably kind of be more involved with library and museum and archive aspect of work as well. Thank you.
Thank you. Is there anyone here actually currently working with some of the sort of less traditional computational areas, and just what experience have you had in sort of working in these new areas for us? Yes.
So I've worked on a couple of projects, so some with the School of Education at Durham. So that's an agent-based modelling project where the agents are pupils in a classroom, see how they interact. That's something that was started on someone's desktop using NetLogo, and we've migrated this to that and starting to run that on HPC to try and parameterize it. And I think there's a little bit of a sense where we've sort of taken the PI's original code that he wrote and turned it into something that I think he feels like it's sort of got away from him a little bit. And I don't know whether that's a bad thing. I don't quite, but he wouldn't be able to do what we've done with it, obviously. The other aspect that other department I've worked with is the music department. We've done a few interesting things there. And another project where we're trying to do some ML on the music. I've lost track of what we're actually trying to talk about.
Yeah. Thank you.
But yeah, there's lots of interesting stuff that we've been involved in. Yeah.
I think there's one over there. Yeah.
Yeah, there's a term that's not been said yet, I don't think, which is called digital twinning. And there's quite a lot of work done in the domain that I specialise in, which is computational geography, where I guess we're trying to make models of cities, but all the way up to sort of global scale models, running at higher resolutions and in 3D, more than ever before. And the demands for computation in that respect are quite difficult. The demands for the data is quite difficult. We're trying to integrate quite sensitive information sometimes, and think about the smashed glass emergency situations when we need to access this data about where people are and where they've been.
There's another question over here.
About the question how we get these kind of projects. So our department has done quite a lot of outreach in this respect, and our business development manager went into departments and actually gave talks about what we do and how to get in contact with ARC and what we offer. And we run a survey asking people about what they need and what they are doing, but especially the humanities and so on. I think you have to be very open and very interested and talk to people. I mean, just people that you know, or people in your sports club, or people on the schoolyard or so. So all the people who are actually in these projects. And often I find in these conversations you actually kind of find out, oh, actually this person is doing something that's really interesting and relevant, or the other might find out, oh, there is actually some kind of support I've never heard of. And so I think it's, yeah, really getting out there and talking to people and talking to all sorts of people about what they are actually doing, that gets you then in contact and gets you the projects.
Thank you. There's one
Can I
here
just
and there's
add
one
a-
at the back.
Can I just add a
Yes.
follow-up to what Marion said, since she mentioned me there? That essentially, some of the previous sessions we talked about sort of miscommunication and things like that. When talking to an arts and humanities person, you have to listen to what they're saying, and you have to avoid the technology almost. Because as soon as a lot of them, as soon as you start talking technology, they'll switch off. But as soon as you start talking about what the technology can do, and ask them what they are wanting to achieve with their research question or the direction in which they're going, that's when the conversation starts.
Thank you. And I think there was, yes.
I just want to say, like, finding people to signpost to the teams has been quite effective. So if you find people where all the arts and humanities, they talk to their research administrators, helping with their grant development and saying, well, if only I had this type of support, or people putting in grants with computational research in it, but not realising there's an RSC team that could support them. And so having a network of people who can sort of funnel the researchers towards you has worked quite well before.
I think we come back to the sort of the full circle thing. I mean, in a bit, I think maybe Mike back at the start said, we're about anticipating needs here. Well, that's what we're talking about, or we're supposed to be talking about, but we've covered quite a lot of ground. But it's not a simple thing of getting people to tell you what their needs are, or you anticipate, particularly with people who aren't used to using the technology much or don't understand the terminology, it's hard for them to imagine what the research possibilities are, never mind their needs, until you have that conversation with them. I mean, it does fundamentally come down to legwork and talking to people. I mean, I think that's been the theme through everything we've heard today. I mean, it's all about talk and bringing people together who have the expertise in research computing with the researchers. And once they have the research idea, then you can go on to talk about anticipating needs and work together to understand that. I think the difficulty is it's hard for people to imagine even what's possible before they've had those conversations.
Okay, I was going to move on. It's different, try to see if we can get three. Go on, Matt.
Just very quickly, just to follow up on Andy's point. Yeah. One of the things we've done in N8CIR is working with digital humanities as one of our target groups. And we realised early on, if you say to these people, we're going to put on a course on Python, they say, well, why would I want to do that? What's the relevance of that to me? If you can say, here's a case study of where someone has used Python in their research and this is what it's done for them, then they can start to see the message better. So as you say, it's not pushing the technology, it's not pushing the programming platform, whatever it is. It's talking about what it can do for their research and finding a use case that's similar that they can relate to. So we've been trying to collect use cases in digital humanities and then advertising them, and then doing a course on like Python for Twitter scraping for the humanities. And then they say, okay, now I can see why that might be useful for me, and I will do this, not because I want to learn Python, but because I can see this application would be useful for me.
Yeah, that's a nice point too. Let's finish that question there. I'd like to get maybe 3 questions done. Yeah. So if we move on a little bit, in each of our roles, we see trends that are coming along. Things we've done in the past, things we're currently being asked now. Given that information, are we able to sort of make some decisions on the sort of future needs that may be coming along soon, other things that may be coming our way? So sort of rather general question really, do you see any trends at the moment, and where do you think it's going to take us? So everyone has a different role. Yeah, and therefore they will be seeing different trends. They'll be seeing different aspects of it. So it's a fairly general question. Given your worldview, where do you see trends going in the future? Anticipating future needs for software research, software engineering, etc. Yeah, and so everyone will have a different view. It'd be great to see the sort of a range of views and a range of trends, and see if we can maybe learn something from that. Sorry, there's a hand at the back. I was going to do the panel first, but let's. The hand at the back looks.
Okay, so it's supporting non-traditional user communities.
Sorry. Okay, let's do that one. Yes.
And so, I mean, traditionally, a lot of the resources that we're using and data sets that are being onboarded or used are used by academic communities, or within a small niche discipline. And these days, there's more cutting across different disciplines within academia, but actually the users that we're going to have using our systems are not going to be coming from academia necessarily. They might be coming from government, they might be coming from other public organisations, third sector, and we're trying to support the applications that are going to be running on using the infrastructure and integrating the data.
Yeah, thank you. Yes. Right. So, in your role, what trends do you currently see, and how is that going to help us anticipate future needs? Where do you think things will be going? What will you be asked to do in the near future? And where should we start with that one? Go on. We'll start at the one end and work along.
Thanks.
So maybe I don't know, national service or something.
Yeah, I could talk about that.
Yeah.
I mean, a lot of the fake stuff with national service is always, it's anticipating what's not going to change as well. So what do you need to support going forward that still needs to be there? So like NPI, for example, Fortran, these things that have been around for a long, long time now. And that sort of traditional HPC use. Well, I think going back to a few things I've said, the thing that seems to be happening, apart from is that. And I'm less worried about the program models and the GPU stuff and all those sort of things, because eventually, what will happen is what happened with, as Mike was describing, HPCX. Eventually, we'll just have a system with accelerators, and people will have to get on with it and just do science on it. So that'll drive people forwards. But the more worrying thing is the complexity, right? So it's the things we talked about here, like the digital humanities and the data sets. It's the linking those to the HPC and the processing power. At the moment they sit in two different silos. You have sort of safe havens, data set things that sit over here, and you have some services which you can use to analyze and extract meaning from them. They're typically not high performance computing. You might have a large shared memory machine because people doing those sort of things like lots of RAM or something like that. But you won't have a large system like, and on the other side you have Archer 2 sitting there with its parallel file systems, and it does simulation and stuff like that. Actually, how do you link those two things together? So suddenly I want to work on the large data sets and marry them with the high performance computing. That complexity is a trend, I think I see it. I mean, that's no secret, right? I mean, everybody's been talking about data science and HPC coming together for years and years and years, but I'm not sure they've seen huge progress in making that happen for all the vendors.
But in Cambridge, we put data alongside HPC, and we started doing that in 2006 when basically the compute cycle problem was kind of like boring. And as a result, in the HPC system, we host many of the genomic projects. So actually, that a long time ago, it was what's going to happen next. It's quite clear that, data and HPC need to sit next to each other because you can't afford to ship the data. That's bleeding obvious.
It takes
2
weeks.
All right, so we've been doing that for 20 plus years, right? So, some people have been kind of, moving on. There is a great degree of inertia, but it's kind of like boneheaded to separate data from compute.
I was going to do the rest of the panel, but it seems there's some folk who are desperate to stop the blood sort of flowing away from their hand. I'll get some folks in first. They'll come back to the panel again. Mark, then Marion.
Sorry.
Marion, were you first? Sorry, Marion, then Mark.
Yeah, I was just going to read 2 comments from the online participants.
Yes, please do.
So the first one is on your question. performance portable DSLs, Cocos Raja Circle, that abstract entirely over accelerators. And the second one is increased governance, increased segregation of data and processing platforms, secure computing as standard.
What are we doing tomorrow?
Yeah. But, I'll come back to the secure computing one in a minute. That's Mark.
So, without wishing to disagree with either Mike or Andy, which would be a brave thing in both cases.
But please do.
I think this data thing is complicated in the HPC and the data science worlds. I think it's easy to make data available across an entire centre. That's a solved problem from some time ago. The challenge is that the people we have in our data infrastructure at Edinburgh are using things like Jupyter Notebooks. They're very containerised. It's a very, very different world. And what we are trying to solve, but have not yet properly solved, is the ability to start a small problem in the virtualized infrastructure and then burst it out onto the HPC GPU infrastructure. And if we get it right in the next year, we'll be able to do that. And I think that is a really, really important convergence point. But the thing is, you cannot take somebody who's using a Jupyter Notebook and give them an HPC system and expect them to be happy with that. I mean, many younger people have never seen a command prompt, for example, and we just need to accept that.
I think that's disagreeing with me. I think that's the next part of this process. The first thing you need is the HPC and the data together, because you can't afford to move enormous, great big data sets around. And then you need accessibility.
I agree.
Yeah. I wouldn't say, I mean, I didn't say we'd solved the whole thing, but we did perceive that the separation of data and HPC was really not the way to go.
Yeah, completely.
Accessing it, yeah, I agree, it's a different issue.
Marianne, is that more comments?
Yeah, more comments from online. Somebody says, trusted research, NCSC as a requirement for all grant-funded work. And then there's somebody who would disagree a bit with Jupyter, and there is some kind of link that I haven't clicked yet. Okay. And we have it on one of our
Don't
clusters.
click any links.
Yeah. I mean, I think just to tie a point together with what Mark said and what Steve said about open on demand in one of the previous sessions, it was great to see an increase of new users using on demand and Jupyter. But I think we've now experienced this double hump. So you've got a hump of early users and you've got a hump of HPC users, and they clearly outgrow Jupyter Notebooks. And then you're sort of back at the first stage where you need to sort of take away the easy interface that they've got used to, and then they need to go back to sort of square one of HPC use and learn everything from the stack back up.
There was a bit of a chat at the table. I was at a lunch about this, and you know, one thing I think is at least that helps you in some sense, because you've got finite resource to support people, and you end up focusing on the people who need the extra steps rather than getting everybody over the extra steps to start with. So there may be some people who are always happy with the open on-demand stuff, and that's great, right? They're just people that have got an interface, and you don't need to push them over the hump. So maybe it does help you in that sense, but we are still at the stage where we don't. I think what I was getting at with the data thing wasn't done already, but the complexity of making that sort of research work is the trend that I'm worried about. Is you know how, and that all feeds into this interface to it, you know, and how you search the databases and what tools are available on an HPC system for accessing that sort of data and working with it, which just are less there at the moment. But yeah,
right, so I'll let a couple of panellists in on this question, and then we'll go back to the floor again and more comments from online. Yeah, so current trends that you're seeing, and how do you think that will help anticipate future needs? Karen, Emma?
I sort of agree here with the sort of accessibility piece, and you know, we're seeing more and more people who are interested in using something more than their desktop or laptop, but they're also put off by this learning curve, and they don't want to, you know, take the time, and they want to experiment, and I want to encourage experimentation. So how do we bring these two different points together? And is it with open on demand? We're working on using MATLAB just through the GUI, You know, it's an environment people are used to, and then it can run jobs on our local cluster. And it's just sort of finding these different ways to do this. And I think the complexity side is there as well, because we're trying to sort of bring two quite different things together. And at some point, there is going to be a drop where they might just have to learn command line or something like that. So, you know, we also need to ensure there's training available in the teaching side as well. I mean, yeah, and I suppose cloud is another one. But that's for tomorrow.
That's right. Karen?
Yeah, I think I'd agree with everybody on the panel, actually. I think there's a big move so that you have the traditional HPC users, and now there's a big growth in much more data-centric work. And the people who want to do the data-centric work are often people who, with apologies to them, they just want to press go. And in a lot of cases, the software for them isn't keeping up with the data and the facilities that they use. So I do think there'll be a change there. I think that will be a trend, is the software catching up to help them do that. But when you were saying about using Open On Demand or something to get people over that first hump, at least it means they can learn one thing at a time.
Yeah, yes, exactly.
Thanks. Marianne, back to some questions from online.
Yeah, actually not questions, but more
comments.
future trends.
Excellent.
Increased focus on net zero and the excessive use of electrical power for computing resources is one comment here. And again, somebody in Sheffield is disagreeing. We've also had Jupyter for a while now on our main cluster. Some users do struggle a little with it at first. And another link.
And if we reopen it to the whole room, what trends are you seeing in requests and conversations, etc., and how will you build future needs given what you're seeing? Yeah, so if we go for the microphones.
Thank you. So this might be a little bit niche, but coming from Fusion, we've got a whole department that focus on robotics in challenging environments. So we need to remotely manipulate things in active environments, for example. And this was kind of mentioned a little bit in GTC last week as well. A gentleman was talking about having AI-controlled robotics, and that's going to be so the next stage of AI machine learning would be in robotics, and that's probably something that's going to be very relevant to Fusion. And then I guess so the question is going to be whether or not these machines are controlled centrally, or if you do something like developing a model and then deploying it on a chip which exists on the machine itself, using potentially those, starting to see some analog computing sort of matrix calculation chips which you can put on a single object that does one thing. So it would be running that model on the robot. So that's one of the things that we might see, but that's not necessarily applicable to everybody.
So I think that ties in one trend I didn't mention when I was talking that I think we see is a growth in demand for what used to be termed urgent computing. So as models get more and more closer to the physical thing, or machine learning gets closer to the physical thing, and you can imagine this working with robotics as well, is something's happening now. I need to do this powerful calculation now. And you can imagine that could be a robot learning in a new environment. The environment's changed. I want to do something and then push that into the robot to be able to control itself, or something like that. And in terms of large-scale compute, I think that's still quite difficult, particularly with academic computing. It's tough to manage that, and to set the system up in such a way that somebody can come in and just interrupt other people's work and say, I need this now, and the priority. I mean, it is a question, I think, rather than the technology's there, it's a question of policy and training users to accept this sort of thing. But I think that is a trend that's growing because of the more, particularly to do with machine learning, but also because models are becoming closer to reality. Somebody talked about digital twins. I think it was my doppelganger name, Andy.
Do we have any more questions from the room? Well, are you?
You didn't ask me.
Oh, sorry, Mike.
I think one of the things that picks up a number of themes that have been said already is, complex workflows where you need to access data. If the data isn't there, you might need to summon up a simulation, getting all of that interfaced and working within these environments, which I think just picks up a bunch of themes that have been talked about before. So I think that is, one of the things that will be necessary. It's very challenging, but 5 to 10 years. And of course, the elephant in the room that no one has mentioned is, of course, quantum computers. Now, in my field, if quantum computers are successfully invented and can actually do something useful rather than something totally irrelevant, then basically the whole of our careers is over. Which actually isn't too much of a problem, because actually the whole field is moving much more towards the informatics side. And if you had quantum computing, it would just mean that you're actually getting a better input set of data. You probably wouldn't be able to calculate everything, so you probably have a hierarchy of different methods of calculation with different costs and accessibility, and actually would fit into the pattern of where the field is going. So for us, it might be quite an interesting thing. We're already working with hierarchy of accuracies, interfacing simulation with experiment being a reference point in some quantities, and then putting all of that together. Actually, one thing, just picking up a previous point, there's a lot of misunderstanding in the arts and humanities about what data you can do something useful with. So often the conversation in arts and humanities, where you sort of say, well, we've got all these wonderful tools for doing data, and they say, oh, but my data set isn't complete. They don't understand that most scientific data sets are also horrendously incomplete, and yet you can do useful things. So if there's one message to actually get out there, is actually perhaps it's really not this sort of, you've got every bit of data so you can do this analysis, but making the point that actually the tools work on incomplete data sets, and then they may be more receptive. Hand goes up.
Marianne, we've got 2 minutes left. Marianne, a couple of comments from online.
Yes, now actually a question as well, which
great.
Was back to the data transfer problem that Alan had mentioned. Has anyone any thoughts on having better interactivity, dedicated analysis or visualization nodes on remote HPC clusters? Is this likely to be a growing need?
I think Mark is desperate to answer that question.
I am,
because I did it yesterday.
No. On 2 occasions I have bought exactly that, and they have never ever been used, even by the people that demanded them.
Yes. Yes. So Nick up the back has been constantly waving at me in minutes left, and I see.
All right.
Yeah. So we're down to one finger, and so thank you very much, everyone, for this session. It appears that anticipating needs is actually is an incredibly complicated thing. I think we already knew that. I got through 3 questions of the 12 I had written down. Yeah. So for any sort of future workshops, I've got 9 questions left for the organisers. I think we have a half-hour coffee break now. Excellent. It's always time for coffee. And let's thank the panel for their contributions to this, and the audience and online. Thank you very much, people.